Good morning, I'm Anna Ruini for University of Siena. I'm going to present a holistic assessment framework to encourage and promote industrial symbiosis practices. Let's start with a definition of industrial symbiosis. It is a circular practice that aims to encourage traditional separate entities in a collective approach by implementing physical exchange of material, energy, water, and byproduct. This results in competitive advantages for all the components of the network. One of the ways to promote this circular practice is to highlight each component competitive advantage, since enterprises that join the ES are the main implementers of this network. But what are those competitive advantages? From an environmental point of view, they are the avoided impact that the industrial symbiosis approach can grant thanks to the interconnection established among its components. Those interconnections enable the system to use waste, co-product or byproduct of an industrial process as raw materials for another. This lowers the demand of virgin raw materials and its related environmental impact. However, to grant this new flow of material and energy, some additional processes are needed, as well as their related impact. The industrial symbiosis approach can reduce the overall environmental impact of the system and therefore create competitive advantages only if the environmental benefit derived from all the interconnection between the firm exceeds the environmental impact linked with the additional processes necessary to create the network. Now, most of the study in literature focus on evaluating the environmental impact of the industrial symbiosis system, using several methods and indicators. Among them, the most used is certainly the life cycle assessment method. However, only few studies try to assess each component impact, and therefore only few studies define the competitive advantages that each component of the symbiosis system can gain from entering in the network. Those studies usually apply LCA allocation procedures, such as cut-off method or end-of-life method or 50-50 method. Those approaches are useful. However, sometimes they show some shortcomings. For example, the possibility of odd distribution of impact among the components of the network. Let's see an example. Here we have an industrial symbiosis system formed by 3 different firms. Entering in the network will cause a reduction of the overall system impact of 13%. Now, if the common allocation methods are applied, one or more components of the system will gain impact or not see any improvement in their environmental performance. Though this allocation method discourages the creation of the network, since not all the components gain competitive advantages from entering the system, even if the overall impact of the system is lower. This mainly due to the fact that those methods evaluate the environmental impact step by step in a reductionistic perspective. They do not consider the industrial symbiosis system as a complex system, even if it is a network in which the overall interaction between its components is pivotal to reaching the overall environmental benefit. Though, to identify and quantify the individual competitive advantages that each component of the network could gain, it's necessary a double change in perspective. First, it's necessary to move from assess the impact step by step in a reductionistic perspective to analyze the system as a whole from an holistic perspective. Secondly, in order to highlight the competitive advantages that each firm can gain by entering the industrial symbiosis system, we have to change the question that we are asking from how much each firm contributes to the overall impact to how much each firm contributes to reducing the overall impact. From this double change of perspective stems our system environmental gain method. This new allocation method wants to assess not the industrial symbiosis overall impact, but the system environmental gain. What is the system environmental gain? The system environmental gain is defined as the sum of the avoided impact due to the avoided use of virgin raw materials, considering also the added impact necessary to create the network. If the industrial symbiosis practice lower the overall environmental impact of the system and therefore create competitive advantages, the system environmental gain will be a negative number that could be redistributed among the components of the network. In this way, we will have a win-win situation because we are redistributing among the components of the network a negative value. Now, the question is, how should I redistribute the system environmental gain among the components of the network? To do that, we propose the creation of an allocation coefficient. This allocation coefficient has to be a number between 0 and 1, because we are divided all between its parts. Then it has to redistribute the system environmental gain among the components of the network without causing any incongruous gain or loss. At least but not last, it has to consider the context in which the policymakers are acting. Now, we try to create different types of coefficient. I will present only one of them. This is the scale coefficient. It's assigned to all the firms the same percentage of improvement over the baseline, which is the same percentage of improvement of the overall system over the overall baseline. In this way, all the firms are considered equally liable for the overall improvement of the system. Now, let's see the example that we used before. The overall system improved its environmental performance over 13%. By applying the scale coefficient, all the components of the industrial symbiosis system improve their performance of 13%. Therefore, as the whole system improves, as each firm improves their environmental performance. Now, to conclude this presentation, we propose another framework to allocate impact among the industrial symbiosis components in the aim to ensure a win-win situation for all ES components once the environmental benefit of the network has been proved. In this way, all the firms involved in the network should be incentivized to take part in it. Our method incentivizes the creation of an industrial symbiosis system where all the members are asked to impact the least. As a matter of fact, the firms of the chain gain benefit as all the system improves environmental performance. Now, the project that I present is only on a theoretical stage. What we want to do is to improve our framework by taking into consideration different types of environmental indicators. Moreover, we would like to try our methods on complex systems such as climate change and closed loop. In the end, we would like to propose a change in our method by adding at the system environmental gain also the avoided impact derived from the avoided waste. This is the end of my presentation. Thank you all for your attention.